Hello everyone, and welcome. In this lesson we'll focus on rearing black soldier fly larvae.
We'll take you through the entire process, from reproduction to production, and show you step by step how it works.
There are two main stages, the nursing phase and the production phase. The nursing phase covers the first week, when the larvae are still very fragile. After about 7 days the larvae are stronger. They can be handled more easily, or reared on lower quality feed. Remember, only the larvae eat, the adult flies do not. They survive on their internal energy reserves for roughly 2 weeks. Once those are used up, the flies die. The ideal temperature for larvae is around 27 degrees Celsius. Bear in mind the rearing crates can heat up because the larvae generate warmth themselves. Too much heat causes stress, too little slows down growth. The best humidity is between 50 and 70%, mainly to keep the substrate from drying out. If it does dry out, moisten it. Adult flies need a little more warmth, as they don't benefit from the larvae's metabolic heat. During reproduction, keep the temperature closer to 30 degrees Celsius. Like all insects, they are cold-blooded. They need the heat to be active enough to mate. Black soldier flies originate from tropical regions. Larvae don't need light and can be reared in the dark. Flies, however, do rely on it. In captivity this matters a little less, but it's still recommended to provide a light source. A regime of 12 hours light and 12 hours dark works well, with the morning light being most important. In our experience, most mating takes place in the morning. In the wild, males spot females through the reflection of sunlight on their wings. That contrast helps them find a partner. In captivity this signal is less important, since the flies are close together. Natural light, especially indirect sunlight, is best. But for year-round production, it's hard to rely on changing weather and seasons. Artificial light is a good alternative. If you're starting with a wild strain, natural light works best at first. But black soldier flies adapt quickly to artificial light because of their short life cycle. They are highly flexible. Here you see the spectral sensitivity of the housefly. The peaks show sensitivity to UV, green, and blue wavelengths. For black soldier fly reproduction, we should provide those same wavelengths. There are LED lamps designed for this, but other lamps can work as well. Halogen lamps, for instance, emit useful wavelengths and can serve as a good basis. Do note, they also produce heat, which affects the rearing room temperature. Even though halogen lamps don't emit UV, black soldier flies adapt quickly thanks to their short life cycle. So they can be used successfully in rearing.
Let's now look at what the larvae need in terms of nutrition and feed. One of the strengths of black soldier fly larvae is their ability to thrive on many different substrates. These are often side streams or even waste products, such as compost and manure. The rules around permitted feed aren't always straightforward. A common lab standard is high-quality chick feed. On its own, that's not enough. Larvae also need water, so the feed has to be moist. In the lab, chick feed is mixed with water to a dry matter content of around 30%. Our larvae are adapted to this diet. We achieve a feed conversion ratio of 1.31, a yield of 2.5 kilograms per 40 by 60 centimeters crate. Individual weights up to 200 milligrams, and at least 85% survival, nursing phase included. Another standard feed used in labs is the Gainesville diet, originally developed for houseflies. Studies show no significant difference in performance between larvae-fed Gainesville diet or chick feed. In principle, both work equally well. The Gainesville diet is a dry mix of wheat bran, alfalfa meal and maize meal. Like chick feed, it must be supplemented with water. Its physical properties differ from chick feed, mainly because wheat bran absorbs more water, so a little extra moisture is needed. This results in a dry matter content of about 25%. From our own visual, not yet scientific, experience, it's also possible to rear larvae on just wheat bran and water. Wheat bran is highly digestible for larvae. Since it absorbs a lot of water, extra moisture must be added. A dry matter of about 22% seems suitable. The key point, chick feed is actually too rich to use sustainably. It undermines the whole purpose. The value of black soldier flies is that they can grow on low-value streams. So why use chick feed at all? Because it's a reliable laboratory standard. For research, it's important there are no nutritional gaps, so results remain valid. We also have extensive data on larvae reared this way, which I'll share with you. Wheat bran is, in my opinion, also too high value to use as a sustainable feed. It could, however, serve as a booster in the nursing phase, after which you switch to something lower grade.
Let's now consider the physical needs of larvae. Because they live in moist substrates, pH matters. They perform best at around pH 6, with a minimum of 4. The ideal moisture content usually corresponds to a dry matter of 30%. But this depends strongly on the substrate. If you test a potential feed, aim for the maximum water holding capacity, -2%. This means, the most water a substrate can absorb before it pools on top and larvae drown. The 2% is a safety margin. Literature suggests substrates should not be deeper than 10 centimeters. Larvae process small pieces of feed better than large ones. So larger pieces should ideally be pre-treated. For example, chick feed has a pH between 6 and 6.5. The Gainesville diet is similar. Chick feed mixtures usually contain about 30% dry matter, while Gainesville diet is slightly lower, because of its higher wheat bran content. Here is a table with nutritional needs of black soldier fly larvae. It's not an absolute standard, but a guideline to assess whether a feed may be suitable. These values generally work well, though there are exceptions. The aim is to use feeds with the lowest value possible, minimizing competition with the food chain. That's what makes this rearing system sustainable and efficient. As larvae adapt quickly, avoid maximum nutrient levels, unless the feed is a true side stream with no competition for food or feed markets. Another key point, we still know little about the exact nutritional needs of these larvae. What is clear is they don't thrive on very fibrous material, especially if it contains lots of hemicellulose or lignin. Macronutrients need balance. If sugar is high, fat can be lower, and vice versa. Your course material refers to various sources. Check them out, but note that different studies can't always be compared directly, as methods and conditions vary. Here are our own analysis results for chick feed and Gainesville diet. You'll see a clear difference. Gainesville has lower calculated energy, while chick feed is overly rich.
Let's now move on to the rearing process itself. We assume both production and reproduction take place on site. To keep things organized, the life stages are kept separate. As mentioned, flies have different needs than larvae, so it makes sense to rear them in separate rooms. The 4 stages are adult flies, juvenile larvae, production larvae, and pupae. The cycle starts with the fly cages. Eggs are collected and placed in rearing crates. After the nursing phase, the larvae are redistributed across more crates and grown to full size. Some of these larvae are harvested for sale. Others are reared further to pupae. These eventually become flies, which lay new eggs. And the cycle continues. The rearing crates can be stacked, as long as there is enough ventilation. They can also be placed on Danish trolleys.
Each crate must be identified, not only for legal purposes but also for administration. This is done with batch numbers. Every crate gets its own number. How you number batches is up to you. One option is, first the life stage, for example pre-4 pre-pupa, then the start date, for example pre-2022. 07. 27. If you start several crates on the same day, add 1.1, 1.2, and so on. Let's zoom in a bit further on the rearing process. We begin with setting up a fly tent. Pupae where the first flies have already emerged are placed in a tent. The density is between 1 and 2 kilograms of pupae per cubic meter. You can add all pupae at once or in a few rounds, but for hygiene reasons no more than 3 times. Avoid dead flies scattered around the tent, as they build up and cause odors that trigger uncontrolled egg laying. That said, dead flies can also be used as a lure, placed in a fixed spot in the tent. A tent lasts about 2 to 3 weeks, 3 weeks at most, since the flies don't eat and die once their energy is used up after about 2 weeks. Set up a new tent in good time to avoid gaps in reproduction. A new tent reaches its peak egg production after about 7 days. That's also the ideal moment to start the next tent, so it's running smoothly before the old one comes to an end. In this way the reproduction cycle keeps running continuously. After the peak on day 7 you could optionally add pupae in the old tent to use it a little longer. But topping up cannot be unlimited. Otherwise you increase the risk of unwanted egg laying.
So how do we ensure controlled egg laying? We do that with egg-laying traps and a lure substrate. By nature, black soldier flies lay their eggs in dry, dark crevices. We need to take that into account. One option is to place wooden plates against each other with small gaps in between. In the photo you can see the gaps are simply made with elastic bands. Under the trap you place a lure substrate that ferments well and emits odor. The flies lay their eggs near a food source for their offspring. It's best to harvest the egg-laying traps daily, or at least every other day, so the spread in egg age remains limited. By weighing the eggs, you can determine the yield, which gives you more control over rearing. An alternative is to let the eggs hatch directly on the nursing substrate. You then skip the harvest step, but have less control. For the larvae that doesn't make much difference, because you redistribute them later to the correct density anyway. To harvest the eggs, they are carefully scraped off with a knife or spatula. The eggs have now been harvested, or possibly purchased from an external breeder. In the next step they are placed in a rearing crate together with feed. They remain in this crate until the nursing phase has ended, which is 7 days from the moment of harvest. Per rearing crate of 40 by 60 centimeters you can place about 10 grams of eggs. During the nursing phase it is important that the substrate does not dry out, because this causes mortality in the fragile larvae. So moisten the substrate if necessary.
After the nursing phase the larvae must be redistributed. 10 grams of eggs corresponds to roughly 300,000 larvae, which is too many for further production in a single crate. They are therefore redistributed at a density of 20,000 larvae per 40 by 60 centimeters rearing crate. In other words, from 10 grams of eggs in one nursing crate, you make about 15 rearing crates for production. From redistribution it takes about 1.5 weeks before there are marketable larvae for sale, and around 2 weeks to reach prepupae, in the case of reproduction. The amount of larvae can be estimated by doing a subsampling. First mix the substrate thoroughly for a homogeneous distribution, including the corners. Then take a sample within 10 seconds, otherwise the larvae will already crawl back to the edges. Weigh the sample accurately and then count all larvae in that sample. Repeat this at least 3 times. With the average you can calculate how many grams of larvae with substrate you need to weigh to obtain the desired density per rearing crate. When larvae are reared further to prepupae or for reproduction, they must also be harvested. There are 2 options for harvesting prepupae. 1. Sieving, as with the larvae you keep for production. The condition is that the substrate is completely dry and processed. 2. Self-harvest principle. Prepupae are mobile, they migrate to a dry place to pupate. By adding extra water to the substrate, they will leave the crate and seek a drier spot. Place a collection tray under the rearing crate, for example with kitchen paper. The prepupae will gather there by themselves. In that way, you have essentially harvested them automatically. Now the feeding regime during rearing. Adult flies do not eat, but they do drink. That extends their lifespan. Make sure they cannot drown. A drinking system can be as simple as kitchen paper or a cloth that you moisten. You can also mist the tent daily with water. The larvae, on the other hand, of course do eat. During the nursing phase it is recommended to give them a richer feed, a kind of booster. If you use chick feed, the guideline is roughly half a kilogram of feed per gram of eggs. From the production phase they can be reared on lower value feed. The amount depends on the properties of that feed, but as an illustration, with chick feed it is 10 kilograms per 20,000 larvae. You can apply this in one go, but ensure the substrate does not dry out. Add extra moisture if needed. When should the larvae be harvested? That obviously depends on environmental factors, but typically it is about 15 days after the eggs hatch. If you provided the feed in one go, it should normally have been fully converted by the larvae. The substrate will then be dry and crumbly. To make this visual, in this graph the harvest moment is marked with a green cross. That is the point at which the larvae have reached their maximum final weight. After that the weight decreases, because they transform into prepupae. The harvesting method is essentially: the larvae are separated from their substrate using a sieve with a mesh size of 2 to 3 mm. For larger operations a vibratory sieve is recommended to limit manual labor. The substrate must be dry and processed to separate the larvae easily.
First, some small recap. We start with the nursing phase. These are the first 7 days. Place eggs of the same age in a separate rearing crate. A typical larval density for the nursing is 10 grams of eggs per 40 by 60 centimeters crate. Keep the substrate moist to avoid mortality. After the nursing phase, a redistribution for production is needed. Redistribute to 20,000 larvae per 40 by 60 centimeters crate. From 10 grams of eggs in one nursing crate, you typically create about 15 production crates. It is better to use a richer diet in the nursing phase. For example, chick feed plus water, with around 30% dry matter. Use around 0.5 kilograms of feed per gram of eggs. After the nursing phase during production, you can use a chick feed with around 10 kilograms of wet feed per 20,000 larvae. Feed can be given in one go, but ensure the substrate does not dry out. So, add moisture if needed. Harvest timing is typically around 15 days after hatching. Harvest at the point of maximum final weight. Afterwards weight declines as larvae turn into prepupae. To separate the larvae from the frass, you can use a 2 to 3 mm sieve for small-scale operations. For pilot or industrial scale, it is better to use a mechanical vibrating sieve. The substrate must be fully processed and dry to separate larvae easily. The prepupae can be harvested in two ways, either sieve, as with production larvae, or use self-harvest. For self-harvest, add extra water so prepupae leave the crate. Collect them in a tray under the crate, for example lined with kitchen paper. For the reproduction tents, you can start with 1 or 2 kilograms of pupae per cubic meter. A tent lasts 2 to 3 weeks because adults do not eat and die once their energy is spent. The peak of egg laying is around day 7. Start the next tent in time to avoid gaps. The optimal environmental condition for the larvae are around 27 degrees Celsius and 60% relative humidity. The flies require during reproduction a higher temperature of 30 degrees Celsius and 60 to 80% relative humidity. 12 hours of light and 12 hours darkness is a good light regime. The flies can adapt well to artificial light. UV, green or blue wavelengths are effective.
For black soldier fly rearing, only a limited set of materials is needed. You'll need a suitable light source for reproduction. This can be a specialized BSF LED lamp, or a halogen lamp that provides UV, green and blue wavelengths. Flies are kept in cages or tents, where egg-laying traps with a fermenting lure substrate are placed. The larvae are reared in crates, often 40 by 60 centimeters in size, which can be stacked on dollies or Danish trolleys for easy handling. When it is time to separate the larvae from the substrate, you can use simple hand sieves of 2 to 3 millimeters, or a vibrating sieve for larger scale production. Feed substrates often need pretreatment. For this, equipment such as a blixer, a vegetable cutter or a shredder can be used. Other practical tools include kitchen paper or cloths for a simple drinking system for adult flies, spray bottles to keep substrates moist, insect mesh or pop-up covers for crates, collection trays for self-harvesting prepupae, scales for weighing eggs and samples, and spatulas or knives for egg collection. Together, these materials form the basic toolkit for an efficient and well-organized BSF rearing system. Overall, I have good news. Very few diseases are known in black soldier flies. We would like to keep it that way. Always ensure good order and cleanliness in the facility. Take precautions against pests and possible contamination. Place insect traps to keep other insects out. Bear in mind that the substrate for black soldier fly larvae can also be attractive to the housefly, Musca domestica. If you do not want to rear those, you must also keep them out of your rearing. Therefore, cover larval crates with insect mesh, or use, for example, a pop-up tent. Never feed larvae to other larvae. What black soldier flies can encounter, however, is mold growth on the substrate. Because they live in moist substrates, mold also likes to occur there. In itself, that is not always a major problem, but it is during the nursing phase. Larvae younger than 7 days cannot cope with it. Older larvae usually resolve it themselves. The danger is that mold exhausts the substrate, leaving the larvae with less feed available. Fungi also draw moisture, which can cause the substrate to harden and the young larvae to become stuck. They can then no longer move and may die. Here you can see, for illustration, what the substrate should look like, and next to it an example of extreme mold overgrowth. How can you avoid mold during the nursing phase? Firstly, by working as hygienically as possible and using clean materials when you start the eggs. To limit mold, it can help to thoroughly stir the substrate on day 3 and day 4 of the nursing phase. If mold is already present, it helps to add extra moisture while stirring. Moistening keeps the substrate softer, so the larvae can still access water. Once they reach 7 days old, further intervention is rarely needed. From then on, they usually manage by themselves. Right, that's it. Thank you for your attention.